This is Mrs. Boots, and now we're going to discuss the determinant and the inverse of a matrix. Kind of crazy, but it's actually super simple. You see, there's really only one rule, and that rule is that the matrix has to be square. You're going, square? What's square? Okay, so my matrix must be square. Okay? We're not talking about lingo from the 50s as to whether or not it's cool. What we're talking about is that the number of rows has to equal the number of columns. So if I have 2 rows, I have to have 2 columns. If I have 3 rows, I have to have 3 columns. The numbers can't be a mismatch. Otherwise, we cannot take the determinant. So how do you take the determinant? The determinant, think of it like a cross multiplication. I'm going to take first row, first column, and multiply that times the second row, second column. So we're representing these with letters A times D. Then we subtract. And we have to go the other direction. Okay? So the other direction, I do B times C. It's that easy. Simplify that and you get your answer. So let's do a couple of short examples. 2 by 2s are the easy ones. Then we'll do some 3 by 3s. Okay? So we multiply. 3 times 3. I'm just going to write it out as 3 times 3. We know we have to subtract. And now we're going to multiply the other direction. The other direction, we have a negative 4 times 5. So let's work that out. 3 times 3 is 9. Negative 4, positive 5, negative 20. But we have a double negative here, so that's a positive, so we're going to add 20. So what's 9 plus 20? Yeah, 29. So the determinant of that matrix is 29. It's a single value. We take that determinant and we're going to do something with it when we find the inverses. But for right now, we're doing a baby step. Okay? Let's do example 2. Again, 1, first row, first column. Start there, multiply down. So this would be 3 times 6. You know you're going to have to subtract. Now you do next corner down. So I have a negative 2 times a negative 4. Here we're going to get a little crazy with it, right? 3 times 6 is 18. Easy enough. I'm going to go ahead and keep that subtraction sign. Negative 2 times negative 4 is positive 8. Okay, so I have 18 minus 8. Answer is 10. So the determinant of this matrix is 10. 2 by 2s are super easy. Again, it looks like a cross multiply. In the next 2 examples, we're going to do 3 by 3s. All right, let's look at example 3 and example 4. We're going to find the determinant for a 3 by 3 matrix. Now, this may be a bit confusing because on the 2 by 2, it was very clear. You had a corner to corner, corner to corner. You cross multiply, you're good. With the 3 by 3, you really only see 2 diagonals, right? I got 3 numbers on the diagonal going down, 3 numbers on the diagonal going up. So what do you do with the other numbers? Well, the first step is to write in an extra couple columns. You're not making the numbers up. Watch. I'm going to write the first column over here. Now, yes, it's obvious I made this problem up because all the numbers are just 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So all I did was rewrite the first column outside the matrix. It's there as a reference point to help us when we go through and do our multiplication and such. Okay? I'm going to do the same thing with the second column. Negative 4, negative 5, negative 6. So now I see that those first 2 columns are written out. So now my matrix looks like it's got 5 columns instead of 3. This is important, okay? The first step is to do what we call the downs. You may be confused by that, but it's okay. So I said the 1, go down the diagonal. There's a down right there. 1, -5, 9. The next down, -4, 8, 3. The last down, 7, 2, -6. Okay? So we're going to put that all together. All right? This is what we do. So I have 1 times -5 times 9. Yep, it's going to get big. Big numbers, crazy numbers. Plus the next down. -4 times 8 times 3. Plus last down. 7 times 2 times -6. Okay? These are all my downs. So remember when we cross-multiplied, we did the downs minus the ups. You're like, what? There's more? Yes, there's more. Now we got to do the ups. So I got to start at the bottom corner and go up. So my first up starts at the 3 and goes diagonally up. Then I do the -6 and I go up. Then I do the 9 and I go up. All right? So we're going to do all of our ups. Remember, it's downs minus ups. And yes, you can do this with 4x4s and 5x5s and 6x6s. And it's always downs minus ups. Okay? So let's go with our ups. So I have 3 times -5 times 7 plus, next up, -6 times 8 times 1 plus, last one, 9 times 2 times -4. Okay, so now we get to simplify it. Yes, you can use a calculator. It's easy though, okay? So we would do -1 times 5 times 9, right? And I'd have like -45, and this is a minus here. This is 14 times 12, no, 14 times 6 or 12 times 7. And we go through and do that. Or you can punch the whole thing in the calculator all at once. This whole thing. Just remember your parentheses. When you punch in that whole thing, guess what you get? For the first one, you get -2, 2, 5. Double check me. Make sure I punch my buttons right. Okay? That's my down. -225. I got to subtract. Let's see what we get on the other one. Here's the fun part. Guess what we get? We also get -225. Isn't that cool? I did not plan that out. Okay, I randomly picked numbers, and this is how it ended up. And I just think it's awesome. Okay, but I'm a nerdy math teacher. So now I have -225 minus a -225. Well, two negatives cancel, make a positive. So I have -225 plus 225, which equals 0. All that work for nothing. Yes, all that work for 0. But that's okay, because we have another example. We're going to do the exact same thing. We're going to do our downs, we're going to do our ups, and we're going to get our determinant. And they're not always 0. In fact, I'll give you a hint. When it's 0, that means there's no inverse. That means we can't solve the matrix. There's no solution. That's not necessarily a good thing in life. We like answers to questions. Okay, do you remember the first step? First step, write the extra columns. Column 1, write it first. So what's in column 1? I have -3, 0, 3. Now I need to write column 2. Let's write that one in. Column 2, 2, -1, 0. I have my columns written in. Now what do? the downs. We're going down, okay? So I start at the top corner, go down. 1, 2, 3. 3 by 3, I should go down 3 times. Now, if it's a 4 by 4, guess what? 4 times, okay? So we're going to do our downs. So what have we got? I have you read them off to me if you're in the classroom. So we have a negative 3 times a negative 1 times a negative 3 plus. Second one, we have 2 times negative 1 times 3 plus negative 3 times 0 times 0. Well, we know what that's going to be, right? Spoiler alert. Now remember, it's downs minus ups. So let's see if we can fit this in here. Now let's do the ups. Start at the bottom corner, go up to the top. Go up and go up again. 3 ups. Match my 3 downs. So I start with the 3. I have 3 times negative 1 times negative 3 plus 0, negative 1, negative 3. Well, that one's going to be, yeah. Then I have negative 3, 0, and 2. Yeah, spoiler alert on that one, right? Okay, let's see what we got. So we plug the first one in the calculator. Everything inside the downs, plug it in into the calculator. Well, we already know this part's 0, so we don't even care about that one, right? So I got negative, 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 so I'm going to get a negative. That's a negative 9. Plus, oh, that's going to end up being a minus 6. What's negative 9 minus 6? Yeah, negative 15. So my downs, I have negative 15. Okay, that's my downs. Now you may be asking why I use brackets here. The brackets are not because it's a matrix. The brackets are just because I've got way too many parentheses in there. And so I use the brackets to indicate that all this stuff goes together. So now I need to go do the ups. We got all our downs done. Let's do the ups. So we had 3, negative 1, negative 3. That's going to give me a 9. That's 0, that's 0. So this is a 9. Kind of anticlimactic on that, right? I wanted more numbers. You're probably just happy there aren't. Okay, negative 15 minus 9. What is that? Yeah, negative 24. So my determinant for the matrix on example 4 is negative 24. Now, we're going to do some examples where we're going to take our determinants and use that to find our inverses. Don't worry, we're just going to do some simple 2 by 2s. Now let's do our inverses. So we have 2 examples, but before we do them, we need to go back and make sure that we have the notes down, okay? So we have a matrix A. It's our ABCD matrix. I was so original with that one. To find the determinant, what do? Cross multiply, right? So we have the A times the D minus the B times the C. Super easy. Well, matrices, you actually can't divide them. It's kind of weird, right? Remember, the opposite of add is subtract. The opposite of multiply is divide. Well, another word for opposite is inverse. So in order to divide it or move a matrix to the other side, which normally we would divide, I'm going to take the inverse instead of dividing. It's a fancy word for saying we're dividing. To do the inverse of a matrix, this is what happens. We take 1 over the determinant of that matrix. So if our determinant is 0, we can't divide by 0. We don't have an answer. Okay? We're going to swap. Yep, we're going to swap. D and A. They change positions. B and C stay where they're at, but they change signs. So the B and the C change signs. So I swap A and D change the sign of B and C, okay? That's what we're going to do on these problems. So first step is find the determinant. So I need the determinant of matrix B on example 5. So I got to cross multiply. So I have 3 times 6 minus negative 4 times negative 2. 3 times 6 is 18. That's going to be minus 8, right? Well, that's 10. So my determinant is 10. That's the first step in doing my inverse. So I know I've got 1 over 10. Easy enough. Now, what changes places and what stays? Well, remember the 4 and the 2 stay. The B and the C stay. A and D change places. So my 6 and my 3 swap. B and C change signs. The 2 was negative, it became positive. 4 was negative, it becomes positive. But now I have a number outside my matrix. Everything gets distributed. You're like, but it's a fraction. That's okay. We just divide everything by 10. Not a big deal, okay? So we would have what? That would be 6 over 10, 4 over 10, 2 over 10, and 3 over 10. Yes, we are going to simplify. 6 divided by 10, that can be reduced to what fraction? 3/5. 4 over 10 is 2/5. 2 over 10 is 1/5. 3 over 10 cannot be simplified, so it stays. So our inverse matrix looks really wild. We got all those fractions. Well, think about it. If you have a number being multiplied, what do? You divide it. And so we're dividing. We're multiplying by the inverse. It's a division. So instead of dividing by 2, I multiplied by 1/2. Think about that. Dividing by 2 is the same thing as multiplying by 1/2? Yeah, it's the exact same thing. Okay? 1/2 of 4 is 2. If I divide 4 by 2, I get 2. So it's okay. We can do that. Let's do example 6. First step, we got to do the determinant, right? So let's come over here. I need the determinant of matrix C. What are we going to do? Well, remember cross multiply. So I have negative 6 times 7 plus, is it plus? Ooh, it's minus. Negative 4 times 11. Okay? Now it's going to end up being a plus, but that's okay. Okay, negative 6 times 7 is negative 42. 4 times 11 is 44. 2 negatives make a positive. What is that going to be? Yeah, 2. So my determinant is 2. So for my inverse, I do 1 over 2. Okay, remember, you're always doing 1 over the determinant. Now let's put the matrix in. Who changed places? Do-si-do. Grab your partner, swing them around. Okay, the 7 and the negative 6. 7, negative 6. They change places. The 11 and the negative 4 stay in the same spot, but we got to switch the signs. 11 was positive, he becomes negative. 4 was negative, becomes positive. Now all we have to do is take our pretty little 1/2 and distribute to everything inside. Don't worry about it. It's easy. Okay, let's do that. So, I now have 7 divided by 2, negative 11 divided by 2, 4 divided by 2, and negative 6 divided by 2. Equals. Let's simplify that. All right, 7 divided by 2. What's that going to be? Yes, you can put decimals. Do you want to put decimals on this one? We'll do that. Okay, 3.5. All right, negative 11 divided by 2. Yep, negative 5.5. Isn't 0.5 the same thing as 1/2? Yeah. 4 divided by 2, 2. Negative 6 divided by 2, negative 3. So that is my inverse. In the next lesson, we'll show you how to take that inverse and use it to solve problems so that you don't have to do the systems by substitution or elimination.